Hi everyone, I'm Julia from Krannich Solar. Thanks for joining our webinar today with Yotta Energy. Before we get started, I'm just going to give a quick presentation about Krannich. Krannich Solar is headquartered in Germany and was founded by Kurt Krannich. Since being founded, Krannich has expanded into 26 different countries and can ship to over 100 countries. As a privately owned and self-finance company, we hold a significant market share and rank among the leading solar wholesalers globally. With 29 years of experience in delivering solar products worldwide, we become experts in our field. Our international purchasing power helped us build strong relationships with your favorite manufacturers, such as Yotta, to secure the best pricing and availability. In 2005, Krannich expanded into the US, opening our first branch in New Jersey. Today we have branches in California and Florida, and we're expanding into Texas, with additional warehouses across the nation. Our US team consists of over 80 employees and services the Americas and strive to offer the best services and options to our partners. We are growing every day, so keep an eye out for where we might be next. Krannich is the top partner for installation companies seeking PV system products. In our role as an internationally operating wholesaler, we can make a significant contribution to shaping the energy transition. With every PV system we supply, we come closer to the target of carbon neutrality and fulfill our mission of paving the way to 100% renewable energies. Our company values are the drivers of our success and our inspiration in a dynamic market. Throughout the years, we've grown our product portfolio to provide over 5,000 products. We partnered with leading manufacturers worldwide to offer the best material for a project of any size, whether it's an off-grid system, 4-panel shingled roof, or a megawatt flat roof. Choosing Krannich Solar means you'll never work alone. Our streamlined ordering process ensures that each customer receives a dedicated sales rep, guiding them through every step from project design to on-site delivery. The solar industry is always innovating and changing. At Krannich, we're committed to keeping you informed about the latest products and technologies. We collaborate with industry leaders and seasoned professionals to offer first-hand training on everything you need to know, and it'll always be for free. And this concludes my portion of the webinar. Here's our contact information if you'd like to reach out for a quote, or if you have any questions regarding the products or services we offer. And if you have any questions throughout the presentation, please feel free to ask them using the question box, and then we'll answer them at the end of the presentation. Thank you again for joining us, and now I'm going to pass it along to the team from Yotta.
All righty. Well, thank you so much for that introduction, and thank you so much for taking the time out of your day today to spend time with Krannich and Yotta Energy. Can everyone hear me?
Sounds good to me.
All right, perfect. Let's get started. Yotta Energy is a company founded in 2017, located in Austin, Texas, and we currently have about 40 employees. What we're trying to do is trying to lead the change from your standard centralized ESS system to this distributed energy on the roof, utilizing the space that's already available and basically displacing ballast blocks with usable energy sources. One question that we do get asked quite a bit is, how do you pronounce your name? A lot of people will call us Yotta. That is not correct. It is actually Yotta. I thought this was a really fun slide to kind of get things started with. So the next logical question is, okay, so you're Yotta, but what does that mean? What does that Yotta actually mean? So Yotta actually means 10 to the 24th power, or 1 septillionth in the international SI system. Basically 10 to the 24th looks something like this. We're all familiar with the kilogram, megabyte, gigabyte, terabyte, petabyte, right? but now we're going all the way out to Yotta, which is the Y, or 10 to the 24th 1 septillionth. This just kind of puts things in perspective. What we're seeing is that the sun gives the Earth about 1.6 Yotta joules per day of sun. All right, so the agenda today is going to be pretty quick. We got about an hour ago, and we're going to talk about the energy introduction of our systems. We're going to talk about the solar leaf, the solar, we call the Yotta Vision, and the DPI, which is our 4-port microinverter. We'll talk a little bit about some tech sheets, the thermal engineering, the kind of secret sauce that we use to be able to put the batteries on the roof, what we call it a smart battery, being able to see it remotely, and also the microinverter itself. We'll talk about some of the use cases and kind of white papers, if you will. Talk about DC clipping, time of use management, demand charge management, and demand response. These are all very important things when we're talking about energy storage. We'll talk about the design of the product and how to install it. And then, of course, wrap up with some questions. Let's start with the Yotta ecosystem. The Yotta ecosystem is very simple in the sense that starts with a module, goes down to what we call the solar leaf, down to the 4-port microinverter that goes directly into your electrical box. Very, very simple system, all of which module, battery, racking, and inverter live directly on the roof here. We also do have a line of Yotta EV car chargers, level 2 chargers today that are readily available, and actually will communicate via the gateways to the solar leaf, to the inverter, and then to the EV charger. We call this a PV coupled system because what we're doing is we're taking this solar module that's sitting on the roof, up to 750 watts. Solar module plugs directly into the input of one of the solar leaf batteries. The output then will go into an input of the microinverter itself. This again is a 4-port microinverter. We call this the DPI, or dual power input, because you're able to actually put the module directly into the inverter, or module through the battery into the inverter. The inverter itself will recognize if it's just a module or just a battery. All of which goes down to a 10-gauge trunk cable, down to a 30-amp 3-pole single-throw breaker and an AC sub panel, all the way out to the main service panel. Again, we're trying to put this together as very simple solar. This right here is just a bit of a schematic for it, but you can kind of get an idea as far as the PV, battery system, inverter system, all the way out to the meter. We say this is an ideal combination because Yotta Energy right here will have the DPI 208 and 480 volt microinverter. Now this one is very important because this is a low voltage system. This is basically line voltage, higher production because if it's a microinverter. You have module by module visibility, rapid shutdown compliance, and easy to troubleshoot because you know exactly where these products are. You know exactly if there's any issue with a module, an inverter, battery, all remotely being able to see it through our Yotta Vision system. The solar leaf itself is a modular and scalable. What we can do is just put this behind every single module. But saying that, it's not required. It really depends on your needs for energy. Your energy usage, it really depends on what your calculations are for your building. Having information about your system, your energy usage, we can go through calculations and determine how many batteries are needed for your system. Batteries today are a 1 kilowatt-hour system and can be expandable. The only limitation we currently have is the number of modules on the roof. I need one module to charge one battery to go into one single port of the 4-port microinverter. This right here is just a quick graphic. It just shows you how it all puts together. What we're looking at here is an example of panel claw racking on the ground. You can see the inverter tray that falls in, which provides the racking for the inverter. We then see the solar leaf being dropped in adjacent to it. You see the inputs and outputs. The input comes, of course, from the module. The output goes into one of the 4 ports of that microinverter. We say this is actually the world's first truly integrated solar and storage solution. We believe it. So again, we're talking about the module going directly into the battery, battery coming out into the microinverter. Very simple to install and minimal amount of maintenance required. The product itself is very lightweight, can be easily carried by one person. Architecture, easily to grow. This right here, we're actually able to expand as quickly as needed. Let's just say, for example, if you had 1,000 solar panels on a roof and you only needed 500 batteries, you could do that. But as your energy needs expand, we can actually just plug and play or drop in more batteries as needed to be able to meet your demand. Highest safety in this application, again, we're trying to provide a low voltage system, no high voltage DC anywhere on this roof. The module itself is probably somewhere in the 40-volt range, going into the battery being charged, coming out of the battery, approximately 40 volts, going into the inverter. The inverter then converts that to AC right there. The nice thing about that is rapid shutdown compliant. Everything's under 80 volts, touch safe according to NEC. And we really believe, and we'll talk about this more as we get deeper into the presentation, the lowest cost for the system. So let's talk about some of the tech sheets. This right here, as I said, up to 750 watt modules can be plugged into this product today. Module compatibility, 60, 72, of course, the 120, 144 split cell, and bifacial modules. All of which, the really key piece for me and for Yotta is the voltage and current of those modules. But these particular 160, 72, 120, and 144, I would say most are compatible with the product today and can be used easily. As I mentioned, it's a 1 kilowatt hour battery today. Duty cycle, 800 watts right here. So we're going to charge full and deplete down to 20%. The chemistry, LiFePO, lithium iron phosphate batteries. Number of cycles, 6,000 cycles today. This is looking at about 15 years of cycling back and forth. The important piece right here, all of it's important, but this one's really nice, 52 pounds, 53 pounds almost. It's a single person lift, easy to get to the roof, easy to install, easy to service if needed. Pounds per square foot, this right here is 2.7 to 3. This is your typical, but basically what's nice about this, people always ask, well, what if we had to add this, how much more weight does this add? The answer is zero. It's a zero net gain because you're going to basically remove 2 blocks and put this in its place. So basically zero it out what you've done on the roof. It can do flat roof or ballast racking. Ambient temperatures right here, looking at this is what we're looking at, ambient temperatures up to 65 C, 150 degrees F on that roof under those modules. The secret sauce or the module, the chemistry, basically the thermal properties of this device, which we'll talk about more, gives us that ability to go this high. This is the spec sheet of this product. You can scan if you have your phones out right now, you can scan this QR code. It will take you right to our website and be able to download this right now. And or if you go to our website later, it's readily available on our website for download as well. As I mentioned, one of the companies we work with is PanelClaw, and PanelClaw provides us basically a mapping system for the PanelClaw racking, for the modules, and for the battery systems. What they do provide is a module map, or a ballast map. It shows you the number of ballasts that are required for locations. Anywhere you see a 2, a solar leaf can be placed. Actually, it can be placed in a 0 or a 1 as well, but if there is a 2 required, a solar leaf can take its place and act as those 2 ballast blocks that are required for that location. Let's talk about some of the thermal engineering now. This, as I mentioned before, is our secret sauce. This is the 3 things that we do and we do well. And it's actually kind of interesting because I've come from the microinverter world, and at the end of the day, 15 years ago, someone said to me, we're going to put power electronics on a roof and make it last for 25 years. It was kind of a laughable statement. But over the last 15 years, technology has gotten better, designs have gotten better, and microinverters are here to stay. It's kind of the mainstay in most residential today, and we're seeing a big influx for commercial jobs as well. So we took the technology from the microinverters and applied it to the battery. Batteries themselves want to live and breathe and work in a really comfortable environment. And for this particular chemistry, LiFePO, but it wants to be between 70 degrees F and 100 degrees F. That's where it really likes to be and be comfortable. So what we've done is we've created this Yotta temperature range. And by the way we have done that, we've used kind of a vacuum-packed ceramic boards. And those ceramic boards right there act as a thermal barrier from anything that is on the outside trying to get into the, so if the outside temperature under that module raises really high, vacuum is a very, very poor conductor of heat. Think of it like a thermos that you bet in the morning. You put your coffee in a thermos in the morning, and then when you open that up at 10 o'clock in the morning, the coffee is still hot. That vacuum insulated thermos gives you the ability to put that product in there. It keeps it warm and keeps any kind of heat that's inside from going out, anything from outside getting in. It's really critical. That's number one. Number two, we use a phase change material, which gives us the ability to absorb any heat that's made from inside the product. So let's just say during charging or during discharging, heat is generated inside the product. What we're able to do is actually take that heat, put it into this phase change material, store it, and then use basically a unidirectional thermal siphon to be able to pull that heat out to the outside of the case. And you can see right here, we have these vents right here. This right here is kind of a heat sink, if you will. All that heat is being drawn out of the device to the outside of the case where it can dissipate. So this is exactly how we're able to keep everything in between that 70 and 100 degrees F. You may ask, hey, you know what? I live in New Jersey, I live in New Hampshire, I live Wisconsin, it gets cold up here. We also have a way to create heat or put heat back into the device to make sure that these batteries, again, stay in that 70 to 100 degrees F range. We have thin film heaters in between the battery packs that can be turned on and can be used to maintain that temperature within that Yotta temperature range. One thing I do want to point out is it is a passive system. There are no moving parts. There's no moving fans. This all happens through thermodynamics. And again, that is, we have 3 patents on this particular product right here. This is exactly where our technology comes in and gives this product its life. As you mentioned, low voltage system. Everything on that roof at the time of shutdown is under 80 volts, right? All the DC is definitely under 80 volts. We're probably looking at 40 volts or less in most cases. LFP chemistry technology, the safest in the industry. We have gone through all of the testing, the UL 9540 and 9540A testing. During the testing, we had no external flaming whatsoever. We had thermal runaway, but what was interesting about our testing is we couldn't get it to thermally run away throughout the entire battery pack because of our heat mitigation system. Any heat that was generated in the first battery pack was all removed and put to the outside of the case, eliminating these thermal runaway across the entire battery pack. Very, very cool. Also, as I mentioned, that thermal ceramic blanket, this also acts as a fire blanket. So if there is any kind of heat in there, that blanket will actually deflate, and that ceramic material will lay down onto the batteries, kind of acting as a thermal blanket as well. The other nice thing is distributed by design. As you can guess, these are distributed on the roof, and they're all under each module. Modules today are quite large, and that gives us the ability to have 3 feet or more of space between all the devices, then not requiring any kind of fire mitigation system on the roof. No fire suppression required. Rapid shutdown requirements, of course, that's still valid here. As I said, UL 9540, 9540A, UL 1973, and 1741, SA and SB. Of course, in California has their own, so we're also required. We're also on the CEC listing for the inverter and also for the battery. The JA12 listed, and then of course Rule 21 or the NEC 690.12 rapid shutdown requirements. Let's talk about the smart battery technology now. With the smart battery, we're actually able to do 3 things right out of the box. Time of use. So this is actually in many jurisdictions, especially California and other places around the country as well, where power prices go up at certain times of day. So in California, for example, from 4 p.m. to 9 p.m., the price of power almost doubles. So this is a great time to be able to charge batteries in the morning and then discharge those batteries in the afternoon. to actually you basically use the power that you've created or saved for those more expensive times. Demand response. This right here is, let's just say a customer or the utility wants to get in and actually access your power. They're actually able to see your state of charge of your batteries and actually discharge your batteries as needed. If you want them to, you have to allow them to. It's kind of very similar to the Google Nest program when they can get in and turn your thermostat up or down. Same thing here. If they need power, they can reach into your system, grab the power. They pay you for it, which is quite nice, and they actually pay you quite handsomely for it. So it's nice to have that ability. So it's kind of a revenue generation source on your roof, readily available to your utility. And then, of course, a big one here, demand charge management. We're actually able, through the energy tool-based acumen, to be able to monitor the incoming power and also the consumption. So we're actually able to see what's being consumed. If there's any kind of demand spike that happens, we're actually able to then discharge the batteries at that time to reduce those demand charges. Typically, demand charges happen for a 15-minute window. So we push for 15 minutes again and then check again to see if there's any continuous demand for that product. And this is just more of a definition of what we just talked about, time of use. So again, evenings and afternoons, very expensive. Demand charge management, again, peak shaving, what we want to call it. There's many ways to say it, but we're just trying to make sure that we reduce the amount of power that you're taking from the utility during those, especially those demand spikes. And of course, the demand response. We're seeing a lot of this happening in the East Coast as well. I think Connecticut is driving this right now, to being able to reach in and grab power when they need it, and of course pay you for it. Let's talk a little bit about monitoring. All of this is really great, but if you can't see it remotely, then what's the point? The nice thing about this is we actually have Yotta Energy monitoring and notifications. So if there's any kind of issues on the site, the nice thing about this is you can reach in, you can log in anytime, either on your computer or your phone, to be able to see what's going on your particular site. The nice thing about this is it gives you the ability to see both the batteries, state of charge, what they're doing, and also the inverter's performance. If there's any kind of issue whatsoever, you're actually able to see it, and we will be able to troubleshoot. And if you need to roll a truck, you'll be able to actually roll the truck with some knowledge and the right product to fix the issue. Again, saving time and money. These are just a couple screenshots of what you're going to see throughout the day, throughout the month. You can actually go back and look at the data from the product. So look at the period. You can look at the last 30 days here. Here it gives you a nice graph. You're actually able to see this right here is what we call the compare. You're actually able to compare two inverters on the same exact roof. We're looking at channel 1 of one and channel 4 of another, and see how they track. And this is nice. This is really nice to be able to see performance of a system over time. One other thing, what I love about this is we do not truncate any information. All the information that you have created over the years is all saved, and all that information is readily available for you to be able to pull down and type and export graphs, pictures, PDFs, CSVs, whatever you're looking for. All of that is downloadable, and again, for the life of the system as well. Saying all this is we're putting together this new Yotta Vision. We're calling it Yotta Vision 2.0. This right here, we're going to be able to have all the battery information, all the inverter information, all of which in a single location to be able to see your system, and to be able to have a single location for being able to monitor your product. And all of this is done via the monitoring gateway. The gateway itself is a small little box, plugs into the internet. It can be actually plugged in via Ethernet, Wi-Fi, and or via dongle, a cellular dongle, via a available USB port on the side. The way this thing collects information, we say real-time monitoring of each inverter and battery. This is actually not a true statement. It actually is what we call a 5 and 15-minute rule. So every 5 minutes, this goes out and actually monitors and says, what is your status? So it's looking at state of charge, it's looking at power production, it's looking at voltages, currents, temperatures. All that information is being asked every 5 minutes, and then pushed up to the cloud every 15. So think of it this way. So you have 12 different times per hour that's going to get the information from the site. and 4 pushes information to the cloud. And all of that is done via Zigbee communication. And for those of you that are not familiar with Zigbee, this is a game changer. This has really changed the game as far as being able to communicate reliably to all the products on the roof. In the past, everyone in this industry has used power line communication, and power line communication is absolutely wonderful, and it is actually very good. But the big problem is any kind of line interference, any kind of noise in the line, you're going to have a hard time communicating reliably to the batteries and inverters. I put in Wi-Fi here just to articulate the benefits of Zigbee. Zigbee is very similar to Wi-Fi in the fact that it is a wireless communication protocol. It is what we call a point-to-peer, the point being the Wi-Fi or the router, the peer being the device. So it's a point-to-peer. It has to talk to everyone individually, kind of like in your home or office. Your router talks to your phone, your router talks to your TV, your router talks to your computer, Roku box, whatever, point-to-peer. Zigbee has that very similar. So it's the point, again, being that router or that gateway, talking to all the peers in the field. The extra added element of Zigbee is a peer-to-peer communication. Let's say on this call right now, I see Mike right here. Mike's on the call. But for whatever reason, I'm asking, hey, Mike, how's the weather in Pittsburgh? And he can't hear me. So I'll ask Steve, hey, Steve, can you talk to Mike and ask him what the weather in Pittsburgh is? We'll ask the question. I'll get it back through Steve. Self-healing mesh network. This right here is gold. This right here, when we instituted this, when we went from power line communication to Zigbee, we literally cut our phone calls, our troubleshooting phone calls down by 50% because no longer was communication an issue on the roof. Again, time saver and money saver. Let's talk briefly about the microinverter itself. The microinverter, as I mentioned, comes in 2 different versions. The DPI or dual power inverter comes in 208 volt, 3-phase product, or a 480 volt, 3-phase product. For the 208, it has up to 1,728 watts output for the entire unit, or that means 432 watts per channel. One thing I do want to point out is native 3-phase, line 1, line 2, line 3. This is gold right here, because this is right here is phase monitored and phase balanced. Phase monitoring, if you lose a phase, it will shut down the entire inverter. Again, make it safe. Phase balancing, you don't have to no longer do you have to use single phase inverters and balance around the triangle, the A, B, and C. It's all done inside the device. So again, phase monitored and phase balanced, really nice plug and play. So anyone that's familiar with microinverters can really, we have a lot of residential customers that are now turning into commercial installers because they understand how to install microinverters. The 3-phase piece was a challenge, but now the challenge is taken up by the inverter. Done. As we mentioned, Rule 21, 1741, rapid shutdown compliance, 690.12. Moving on to the 480, all the same specifications, except it bumps up a little bit more in the power, 1,800 watts per channel, so that means 450 watts per channel. Again, and all of the same benefits down here, native 3-phase, 4 modules, phase monitored, phase balanced, and all the things you'd expect from a microinverter. I'll pause here again for a second. If you have your phones out, you can scan this QR code. You can download those specifications very easily. And again, also they're readily available on our website. And this just is another graphic here, a little GIF, just to give you an idea of what this product looks like. Size, a 4-port microinverter. Rapid shutdown compatibility, again, 690.12. More generation per module because, as we know, microinverters were great for anything that's shaded. Everything that's not shaded is going to get producing for more. Everything that is shaded will actually, not produces more. But when the shade is gone, product will work again. 25-year warranty. Panel level monitoring. Again, this is a key piece right here. We had a customer recently that called up and said, hey, I'm a new customer. I tried your product, but I already have a failure. And I said, well, let's take a look. So we were able to log in remotely and see the product. And what we found was, one channel was not producing as much as the others on that same exact inverter. But what was nice about that was the system was able to demonstrate to us both that the module was actually the culprit in this particular case, because the other modules were producing somewhere in the 36 volt range. And this particular module was only producing 24 volts. indicating to me and to him that a diode had been flipped, and so the module was, and it was in fact the problem. He went out to the site with a module. He knew exactly where the module was because of the mapping, and was able to fix the problem, within minutes and not hours. Again, it's another one of those time savers because you're able to identify the problem remotely, and then bring the right equipment to the site. And when you're at the site, go to the exact location and fix the problem. As I mentioned before, if people that are not familiar with trunk cables, this is kind of the way that it's set up right here, understanding how AC trunk cables work. With a 208-volt version, you're able to put up to 5 inverters or 20 modules onto a single trunk line. So what basically you have is an AC piece right here that plugs into a single line all the way down here. And what we're looking for is how much amperage each one of these devices can put. As you see, we're putting them in series, so it's right here, it's 4, then it goes up to 9.6, 14.4, 19.2, all the way up to 24 amps, which is the maximum you can put on a 30 amp breaker. So it's cumulative. If we were looking at a, let's say, 480 volt system, you're looking at 11 units, 11 inverters, up to 44 modules, again, on that trunk cable, 10 gauge trunk cable, all the way down to a three pole single phase, single throw breaker. As far as accessories are concerned, very limited, very minimal. The AC bus cable or trunk cable, it's a 3 conductor, 4 meters between drops. Can use up to a 30 amp, so that's where we get the 30 amp 3-pole breaker. And as I mentioned, 5 units on the DPI 208 and 11 units for the 480. If there's a chance where you need to skip a drop, this right here is the connector cap or a dust cap. It keeps it dust proof and waterproof. At the end of the line, so one side's going to be the home run towards the AC breaker, one side's going to be a cut end. This right here is the AC end cap for that. Watertight, dust tight. One question we do get asked, okay, it's a 4-port microinverter, but let's just say I only need to use 3. That's no problem at all. All we ask is you put on these right here, these rubber dust caps, watertight and dust tight MC4 caps. Keeps everything dry and protected. And of course, NEC requires a tool to disconnect the AC if there's any kind of issue, they need any kind of rework done. You take this right here, this particular product right here, will in fact take the product apart quickly and disconnect, although you can do it with a straight blade screwdriver. So this is the don't believe me, believe them story. We have many case studies, white papers, whatever you'd like to call it, on our website. And I encourage you to, again, use this QR code here or go to our website and download some of these. This is actually the case study where we've done a job at a commercial building here in January. It was actually done in Austin, Texas. Quite a large system, and we used the ETB Ackerman, some product, as I mentioned before, to be able to hit and reduce those demand charges for this customer. So I definitely recommend you take a look, download it now, download it later. Really nice product and very happy customer. This also is another case study located on our website as well. This right here is talking about the peak day. It was one day in Los Angeles years ago that the ambient temperature got up somewhere in the 100 and almost 25 degrees. It was crazy. But the nice thing is you see the green line here is the temperature inside the battery cavity, all of which stayed under that 100-degree threshold that we talk about all the time. This is the key piece. As the temperature rises, you can see the temperature rising inside the device, but we never ever hit that 100 degrees. So that is the key piece, and that's why we have a long warranty, long cycles, all protected underneath that protective shell and technology. This again, feel free to scan it or go to our website. But this just gives you 2 different use cases here: the June curve and a September curve, and you can see, time of day, how much more sun we get. You see, this is their typical curve right here. This is your charging. The green is actually charging the battery here. And same thing here, the battery charge in the morning, stopping. And then in the afternoon, we're demonstrating or showing you this time of use, discharge. Another big advantage of having a battery sitting right there on the roof of a DC coupled system is DC solar clipping recapture. This is one of those things in this industry that's it's very interesting to me in the sense that we want to make sure we overload the DC side to maximize the power coming out of the inverter. With modules getting larger and larger and larger, and as you see, the inverter, the biggest inverter we have today is 450 watts. We want to make sure that we capture as much energy as possible from the module, push it out of the battery, but also capture as much into the battery as well. So if the module is, let's say, 750 watts, and the inverter is only capable of putting out 450 watts, we can store that excess power in the battery and make sure that we're pumping out of the battery 450 watts to maximize the power output. So what we would typically have lost now gets stored in the battery and used for later. Time of use, same thing here, right? You're seeing the time of use chart right here. This right here is normal production. What we're doing is we're shifting it. We're capturing it here and then using it later in the day at a certain time. The nice thing about the time of use system, this could be programmed by you, the user, via your computer or your handheld phone or through an app. Then you can actually discharge at a certain time, at a certain rate, for a certain period of time. Those are the three variables that you can set. And you can set multiple discharges as well. Let's just say you're a business that needs more power in the morning and you have everything turning on at 7 o'clock in the morning. You can discharge for 200 watts for 2 hours or whatever you want it to be, but that's programmable by you, the user, and end user, of course, as well. Demand charge management. This is a big one, and you can see right here. This chart shows where demand charge management charges or costs are the highest. And as you can see, or I think we can all assume, California is one of the highest rates for that. What we're trying to do is level this off. We're trying to reduce these demand spikes right here by being able to discharge during those peaks, those demands. When these happen, this is when we come on and start producing and just pushing more power out of the battery, again, to reduce or minimize the consumption from the grid. We're going to kind of self-supply. Demand response, as I mentioned, this is where you can go. They can respond. The utility can reach in, grab power from your system, discharge as needed during those peak demands for them. But they also provide incentives and pay you quite handsomely for their power. Let's talk about the design and installation of this particular product. We've seen this chart before, but again, just for review, module into a battery into a 4-port inverter down the trunk line, down to overcurrent protection, all the way straight through the meter and out to the grid. One of the big benefits of the Yotta ESS system is the cost equipment and the ease of installation. And this chart right here is kind of nice because it actually articulates some of the hidden costs. When you're looking at just equipment cost, I think that you're looking at the ESS system here as traditional, and then the Yotta system. You may kind of say, hey, it's about the same. But then you start adding in the things that you don't really think about, like the maintenance of a system, how much that's going to cost, engineering and design. Because remember, the traditional system is typically your AC coupled system, not your DC coupled system. With the larger systems, you also are required to do fire suppression. As I mentioned before, NEC does not require fire suppression for our product because we were separated by at least 3 feet from each other. So again, not requiring that extra piece of fire suppression. As an AC coupled system, now you've got independent metering. As our DC coupled system, it's sitting on the roof. An outdoor system would require some kind of a foundation, separate permitting, because it's on the AC side, not the DC side. It's because of the size. You need some kind of lifting equipment. There's a lot of these kind of things that are kind of the hidden costs or the the unknown costs. Electrical disconnects, transformers, and thermal management, right? There's a lot of liquid cooling going on for some of these battery systems. Again, it's a active system, not a passive system like the Yotta solution. The other big one is real estate. I actually talked to somebody in New York City, and they were saying, well, they wanted to put a traditional system in, But the reason they didn't do it because they wanted to put it in the parking lot, and they said that parking spot, that one spot where they wanted to put this battery had almost a $500,000 value on that little piece of land in that city. So I can see those are costs as well. So interesting slide. Just want to articulate this. This next slide actually talks about it again. Again, when you're looking at just the centralized system versus the Yotta system, some of the standard systems, the battery, what it costs, balance of system, that all pretty much adds up. But then you start adding all the stuff together, it runs away pretty quick when you're looking at a traditional system. And there's a lot of stuff: foundation, trenching, landscaping, real estate, fire suppression, transformers, permitting. There's a lot of things that are happening behind the scenes that definitely far outweigh the Yotta system. Let's talk a little bit about the installation. The installation of the system is quite simple. I think we saw the video earlier, but this gives you kind of a motionless system here. Again, we're using the Yotta Energy panel class system here, and you can see that the battery itself, the solar leaf, sits right into the ballast trays. Basically clips right in, and there's a foot you can't see here, which provides grounding for the entire system. Over here is the inverter. There's an inverter tray that provides grounding for the inverter. AC output, DC input, DC output, all of which lives and breathes underneath every single module. You can see here, it's kind of exploded view of the system. Here's the foot that I was talking about, that grounding foot that sits right into the rail. Actually, right there. Drops in place, and then again, it's a ballast block replacement for 2 ballast blocks. Less concrete on the roof, and a 1-person lift. Same thing with the inverter. You can see the inverter here. This is our grounding bracket. This bracket right here, the mount. Then the inverter mounts into this, providing that ground path for the inverter. Just going to run through a few slides here. This is just kind of the installation process. Of course, you're going to start with the racking on the on the roof. From the racking, you're going to make sure that we're going to put the panel in for the inverter. It's going to take these 2 bolts out and put this rack in. This bracket right here is going to provide the grounding, as I mentioned. We're going to tighten everything down, providing that ground path. We're going to then take the inverter, slide it into the bracket. There's actually PEM nuts in the bracket itself, so then you use the standard screws to lock it in place and ground it out. Once tight, you're done. This is what it would look like. From there, we're going to drop the battery into the ballast tray. From there, we're going to make sure that the grounding is done, 3 of a bolt. Add ballast blocks as needed, if required by the drawings from Panel Claw. As I mentioned, this side is the DC input, this side is the DC output. The input comes from the solar module. The output goes to one of the 4 ports on the microinverter. Cable management is important, and with Panel Claw they have custom products here that actually clips onto the rails and was able to manage all of the DC and AC wiring for clean installation. As I mentioned before as well, AC caps, both end cap and internal inter trunk cable, if you will, if you need to skip a drop, if there's any kind of obstruction. This is the complete system: inverter, ballast block, and solar leaf. All of the products, both the inverter and solar leaf, have peelable serial numbers. These serial numbers provide obviously a number, and they also have a barcode. These numbers are used for mapping. This is going to give you the ability to map and tell yourself exactly where each one of the batteries are sitting for future use. If there's any kind of issue in the future, you'll know exactly where those are. Save yourself time and money in any kind of service call. And also provide yourself this information for the module map. Now we're going to install the panel. The module comes in here with these clips. This clip right here just holds onto the module frame. We take this, Now we're going to make sure that we make the connections, DC connections, before we put that down to the module. Once down, we'll load it up and lock it in place. And you're done. Just that simple. Pinnacle also has wire management tubes or rows, deflectors, all of which can be installed after the fact for wire management. And you're done. So one question we do get a lot is, are you compatible with other racking systems? And the answer is yes. Pinnacle is definitely one of the ones that we use the most, but we also work with Iron Ridge, Unirac, Solega baskets. We used them recently on a job. It was fantastic, very quick and easy installation. And also working now currently with EcoFasten as well. If there's a racking system out there that you currently use, you would like us to talk with, put it in the comments, put it in the questions, put it in the chat. We can actually talk to them, reach out to them. We've reached out to all of these people over the years and very good success getting the products on their AVLs and for use with the product with both the solar leaf and the DPI. One of the questions we're going to talk about is the proposals. What does it take to do what we want to do, right? So this is basically cuts from our YouTube page. I encourage everyone to go back to the YouTube after this meeting. Take a look at these. These are a couple of the videos that we've done on installations throughout the country. This is in Monrovia, California, a 100 kilowatt system on a storage unit. We have right here, this is a TCDRS. This is a headquarters for the Texas County District Retirement Center, 52 kilowatts. This is a Polaris site. This is actually in Wilmington, Ohio. This is one of their larger distribution sites, 1.3 megawatt system with the batteries and DPIs. And one that we've just completed was the Charlotte Mecklenburg Police Station in Charlotte, North Carolina. A little bit smaller system, but kind of a high profile police station. Very cool installation out there for that one as well. So I encourage you guys to take a look at these videos and enjoy them. So the question is, how do you get started, right? If you're interested in this product, I definitely encourage you to reach out to Krannich. And what are they going to need? They're going to need information from you. And the basic information, obviously the address of the building that you're looking at, interval data as well. If you have the ability to get data from the system, from the utility, interval data is always the best. This comes typically in CSV format. Once we have that data for a year or more, we're actually able to put that into our number cruncher and be able to provide you with an accurate quote as far as what you need for inverters, modules, and of course, storage to meet your needs. If you don't have access to interval data, and some utilities don't provide it, it's becoming more common that they do, but some don't. A utility bill for the last 12 months will definitely help. But the interval data is nice because then we'll know exactly when you need the power, and we can pre-program it to 9:37 in the morning every day when something turns on. And number 3 is, if you already have an existing PV system, this is something we can look at as well, and we can figure out or try to anticipate what you need for storage needs. These are some of our current partners that we have located throughout the country. I know you folks on the East Coast know exactly what a Wawa is. I mean, you can basically trip over them everywhere in New Jersey and Pennsylvania, and all the way up and down the East Coast. And you see one of their wings outside that has our product on it. Chipotle as well. Chipotle, for many of you may or may not know, Chipotle is going all electric on all their new stores. So every single one of their new stores has this Yotta DPI and solar leaf located on them. We are actually currently retrofitting all auto zones across the country. Half-price books, I'm not sure if that's across the country. It's definitely a southern thing. But these are just a couple examples of some people that believe in our technology and are installing it currently. These are some of the utility relationships that we have. Of course, Yotta Energy, they're in our backyard. We work with them, CPS Energy, Duke Energy, to name a few. But there's a few more on here that you're probably familiar with, PG&E if you're in California, Con Edison, Georgia Power. But these, not to say that these are only ones we're working with. These are some of the larger ones that have taken and adopted the technology into their jurisdictions. Now we hit the section where we have some questions. So I think we got about, what, 10 minutes left to answer questions or anything you have concerns about? We can open up the question section.
The one question that was asked earlier in your presentation was, what happens if my region cannot comply with temperature specs regularly below 4 degrees Fahrenheit where I am? Does that kill the sorry, I can't pronounce this word. Is it applicable? Does it kill if the product is applicable for them?
No, so if you're living in an area where the temperatures drop, that low for long periods of time, the batteries themselves. So what I really need is the batteries are fine. Let me start there. If you live in a cold temperature environment, the PV will be used to warm the batteries and keep the batteries in a warm state. Let's just say, though, you're in a situation where you have snow cover for a few days. The batteries will then take over and actually provide the power to keep the batteries warm. In the event that you have snow cover for weeks of time, the batteries will go into kind of a hibernation mode until the snow melts off, and then the PV comes back to heat the batteries and be able to use them. Hope that answers that question. So it is doable in a cold weather environment. Definitely, there's challenges with there. The only challenge is snow cover. If I have snow cover on the modules for weeks at a time, then it becomes a problem. But it doesn't damage the product. It just will not function because the temperatures are just too low.
Awesome. So another question that just came in was, do you see this being integrated into ETB modeling as an option to pick for BESS in the ETB platform?
Absolutely. So yes, so we work directly with them, and I would anticipate there should be a Yotta button here very shortly. I know we've been going back and forth with their engineering team, so yes. I can't give you a date. I'd be a liar to tell you I had a date. I don't, but we have worked with them. We are working with them directly, and I anticipate something very soon.
So next up is there an ATS type setup where they can be used as battery backup?
Not currently today. So today, as I mentioned before, so it's the time of use. It will be the three things that we do: time of use, demand charge reduction, and basically demand so the utilities can reach in and grab it, the power. In the future, and again, I can't give you a time or date on this, but we will have some resilience with this particular product. I'm anticipating sometime, 2025 or so, to have that product readily available. What we really need is being able to have the automatic transfer switch, as you mentioned, to be when the grid goes out, throw that switch and have an inverter come down and create a grid to create that closed loop system that can keep everything running. So yeah, it is being worked on. The engineering team has that in their docket, just not readily released as a product to date.
Awesome, thanks. Now they're asking, what is the max PV module capacity we can install for each Leaf battery?
750 watts is what we recommend today. That's the largest we can put in. But like I said, it really comes down to the input voltage and input current, and that's all on a specification sheet. So I definitely encourage you to take a look at that.
Now, what software do you recommend for modeling extra solar production with the battery, adding the ability for reducing loss?
ETB. So the ETB actually has a modeling program that we actually utilize, and that's as I was mentioning towards the end of the presentation. Having that interval data, we're actually able to use that data in CSV format, of course, and plug it into the ETB monitor and be able to kind of play with those numbers and figure out what the actual storage requirements are for that site.
Now, can you tell us a bit more about your DR programs, and do you work with VPP aggregators?
We do. So we're working right now we're getting on the list actually with Generac. Generac is actually one of the larger people out there today doing this kind of work. And so we're going through all their approvals, actually reaching into our stuff to be able to communicate via Modbus to the gateway to be able to monitor what's going on, both with the battery and with the inverters. So stay tuned on that. We should have this approval here within the next few weeks.
Sweet. Now, what is the decrease in battery capacity at lower temperatures?
It would really depend on the temperatures. We'd have to do the calculations, but whoever asked that question, let's get in touch with them, and we can go through a case study or scenario with them.
And just to let everyone know, this presentation recording will be sent to you tomorrow. So anyone who's looking for the presentation deck, you will receive it in your email. And we were also asked, is RSD built into the Yotta microinverter? This person
Yes.
got on late.
Absolutely is. Right from the start. So yeah, so basically if power is removed from the system, it is considered touch safe within 1/10 of a second, 100 milliseconds.
Okay, so it looks like the last one that's coming in is, do you offer integration with third-party electric vehicle charging management systems to increase power available for vehicle charging when needed?
Yes, absolutely do. And reach out to one of our RSMs, and they can help you through that process. But absolutely, through our gateway, we're actually able to communicate with third parties and work with those companies as well. We also have our own system as well. As I mentioned from the start, that's part of our overwhelming package. We're able to monitor what's being drawn from the cars, being able to push from the batteries, and from the solar as well. But we're willing to work with anybody.
Sweet. And what I missed was, can I pair this battery with an APS DS3 for residential or single phase use?
No, it's only designed to work with the DPI, this either 208 or 480.
All right, that's all I see coming in. Yeah.
Yeah, I'm sorry to cut you off. There will be a residential product in the future, but this product is definitely designed for commercial CNI.
We had another question coming in asking if there are any fire concerns, especially since it is on the roof.
Sure, I mean, there's concerns of anything, any kind of energy storage system. But the nice thing about this particular system, it's self-contained. It's in its own basic tray. It's surrounded by metal. We went through the 9540A testing, and during that process, during the testing, you're required to do thermal runaway. Because of our thermal properties and thermal management, we were not able to get these things to go into thermal runaway. We were able to extract or pull away the heat from the device. So we really believe that this is one of the better products out there, safest products out there. We're working currently with FDNY in New York, and they're pretty impressed with what they've seen. I mean, they're concerned about having batteries anywhere in this very urban area like that. But demonstrating our abilities via the UL testing is definitely got their attention, especially for these high density urban areas.
Great, thank you. I think that is our last question for today.
Fantastic. Well, thank you so much, everybody. Thanks for taking time out of your day, and thank you, Krannich, for hosting us.
Thank you for a great presentation. And thank you, everyone, for joining, and have a great day.
Thanks, everybody.